Right now, we are living through one of the single biggest industrial transformations in human history. I'm talking about the global energy transition. It's this multi-trillion-dollar shift that is literally redrawing the map of global power. So, let's get into it. To give you a sense of the sheer scale we're talking about, just look at this number. By 2027, the world is on track to invest $577 billion every single year just on electricity grids. I mean, that's nearly double what was spent back in 2020. And here's the kicker. Upgrading the world's wires, that's only one small piece of a much, much bigger puzzle. So that brings us to the big question for this explainer. Where is all of this capital actually flowing? And who, exactly, is building the physical stuff, the infrastructure of our energy future? To really answer that, we've got to break it down into three essential pillars that hold this whole transition up. Okay, let's start with pillar one, the global grid. Think about it. You can't have a renewable energy revolution, you can't have an explosion in electric cars if you don't have a modern grid to support all of it. It's the absolute foundation for everything else. Now, what's really fascinating here is just the raw acceleration. Look at the total spending. It's jumping from $300 billion in 2020 to a forecast of $577 billion by 2027. We're seeing huge growth pretty much everywhere. I mean, Germany is set to more than triple its investment, but you can see two countries are really starting to pull away from the pack. By 2027, the US and China are projected to be in a whole league of their own, spending $128 billion and $124 billion respectively. Put them together, and these two giants will make up nearly half of all global grid investment. So right away, the first part of our new energy map looks like a two-horse race. Okay, so you've got the new grids, but that's only half the story. As you start adding more renewables like wind and solar, which, don't work 24/7, you desperately need a way to store that energy for when the sun isn't shining or the wind isn't blowing. And that, of course, brings us to pillar two, the battery boom. Batteries are absolutely crucial here. They're doing double duty, not only powering the world's growing fleet of electric vehicles, but also providing that huge grid-scale storage needed to keep everything stable. So let's follow the money again. This table shows us the projected investment in building new battery factories for 2025 and 2026. You see, Europe is forecast to invest around $20 billion, the US is just over $18 billion, but then you get to the top line, and wow, the scale is just on another planet. And this visual really tells the story. Unlike that two-horse race we saw in grid spending, battery manufacturing is, well, overwhelmingly concentrated. China is projected to drive 71% of all global investment in this space. That is more than 7 times the investment of the United States. This is the first time we're seeing this major pattern of concentration. But we can go even deeper down the rabbit hole, because what's inside every single one of those batteries? It's a complex recipe of critical minerals, things like lithium, cobalt, and graphite. And this is where the story gets even more concentrated. Welcome to Pillar 3, the mineral foundation. Because look, mining the raw materials out of the ground is one thing, but the real power, the real control, lies in that next step, refining them into the super pure battery-grade materials that this entire energy transition depends on. And if we look ahead to 2030, a really clear pattern emerges. China is projected to refine 61% of the world's lithium, 71% of its cobalt, a staggering 86% of its rare earths, and around 78% of its graphite. But there is one very important exception to this trend. And that exception is nickel. By smartly leveraging its huge ore reserves and actually banning the export of the raw material, Indonesia is set to become the world's nickel refining superpower. They're projected to control over 71% of the market. China, by contrast, will refine just 6%. So this shows the map definitely has other powerful players, but that overall theme of concentration is still there. So let's pull back now and connect all the dots. When we put these three pillars together, the grid, the batteries, and the minerals, a new global energy map starts to come into really sharp focus. So here's the bottom line. According to data from Benchmark Mineral Intelligence and the International Energy Agency, by 2030, China is on track to control over 60% of the world's entire supply of refined critical minerals. Let me show you what that looks like.
There's this undeniable pattern of concentration that runs right through the most critical parts of the energy supply chain. We saw it in battery manufacturing, and we're about to see it again and again in mineral refining.
First up, remember that 71% share of global battery manufacturing investment we saw earlier? Now, let's layer on cobalt refining. By 2030, what do we see? The pattern repeats. It's the exact same story, a 71% share. And for rare earth elements, which are essential for things like wind turbines and EV motors, that share grows to an absolutely incredible 86%. Seeing it like this, one after the other, makes the concentration undeniable. So why does all this matter? Well, this level of concentration in one place creates enormous geopolitical leverage, not to mention significant supply chain risks for pretty much everyone else. And while it can lead to some cost efficiencies, it fundamentally shapes the entire landscape of global competition for the foundational technologies of the 21st century.
Which really leaves us with one final, pretty provocative question. The world is racing to decarbonize and move away from its historic dependency on fossil fuels. But, as this new energy map shows us, are we simply trading one dependency for another?